Look up at the night sky. What do you see? Countless stars dot the darkness. Each one is a distant sun. Many are like our own. Some are vastly different. Their birth is a grand cosmic event, a spectacle of unimaginable scale. It is a story of creation happening right now across the universe. Imagine a cosmic fireworks display, not one that lasts mere minutes, but one that unfolds over millions of years. This is the birth of a star. It is a process of immense power and breathtaking beauty. We are privileged to witness it, to understand how it happens. Science pulls back the curtain, revealing the universe's secrets. The universe is not static, it is constantly changing. Stars are born, stars live out their lives, and stars eventually die. This cycle is fundamental. It shapes galaxies, creates the elements, and makes life possible. Understanding starbirth is understanding our cosmic roots. For millennia, humanity has wondered, what are those lights in the sky? How did they get there? Now we have answers. Science provides a clear picture, though many mysteries remain. Join me on a journey to explore these stellar nurseries. Witness the birth of suns. It's a story written in the stars. Stars are not born just anywhere. They need special places, vast, cold, and dark clouds. These are the cosmic nurseries. They are called molecular clouds, giant reservoirs of gas and dust floating silently in interstellar space. These clouds are enormous, stretching for many light years, holding the raw materials for stars. The gas in these clouds is mostly hydrogen, the simplest element and the most abundant in the cosmos. There's also helium and tiny specks of dust. These dust grains are crucial. They are like cosmic seeds helping the gas to cool and to clump together, setting the stage for gravity's work. These nurseries are incredibly cold, just a few degrees above absolute zero. This coldness is important. It allows gravity to take hold. If the clouds were too hot, the gas particles would move too fast. They would resist gravity's pull. But in the deep chill of space, gravity begins its slow, patient work, gathering material bit by bit. Imagine these clouds as ghostly veils, drifting through the Milky Way. They appear dark to our eyes because the dust blocks visible light. But with special telescopes that can see infrared light, we can peer inside. We see the faint glow of forming stars. These nurseries are hidden cradles where future suns are quietly assembled. Within these giant molecular clouds, not everything is perfectly smooth. Some regions are slightly denser. They have a little more material. This is where gravity starts to win. Gravity is a fundamental force. It pulls everything with mass together, even tiny particles of gas and dust. Slowly, inexorably, it draws them closer. A cosmic gathering begins. This process is not quick. It can take millions of years. A vast region of the cloud, many times the size of our solar system, starts to contract, pulled inward by its own gravity. Like a giant invisible hand squeezing the cloud, this collapsing clump is called a globule. A star is beginning to form. As the globule shrinks, something interesting happens. It starts to spin faster. This is due to the conservation of angular momentum, the same reason an ice skater spins faster when they pull their arms in. The cloud was already slowly rotating. As it gets smaller, its spin speeds up. This rotation is very important. It will shape the future star system. The collapsing cloud doesn't just shrink, it also flattens. The spinning motion flings material outwards, perpendicular to the axis of rotation. This forms a wide spinning disk around the central collapsing core. This disk is called a protoplanetary disk. It is where planets will later form. Our own solar system started this way. A spinning cloud, a central star, and a disk. At the heart of the collapsing globule, the material becomes incredibly dense and incredibly hot. As gas particles are squeezed together, they collide more frequently. This generates heat. Think of pumping air into a bicycle tire. The pump gets warm. The same principle applies here, but on a cosmic scale. This hot, dense, glowing core is called a protostar. It is not yet a true star. Nuclear fusion has not begun, but it shines brightly, heated by the energy of gravitational collapse. It is an infant star, still gathering mass from its surroundings, wrapped in a thick blanket of gas and dust, hidden from direct view in visible light. The protostar continues to grow. Material from the surrounding disk and the larger envelope of gas spirals inward, feeding the hungry baby star. This process can be messy. Powerful jets of gas are often blasted out from the protostar's poles. These jets clear away surrounding material and can create spectacular cosmic sculptures. Eventually, the core of the protostar becomes hot enough and dense enough for nuclear fusion to ignite. This is the magic moment. The star truly comes alive. Hydrogen atoms begin to fuse, forming helium atoms, releasing enormous amounts of energy. This energy pushes outwards, balancing the inward pull of gravity. A stable star is born. Section 5. New Eyes on the Cradle, Webb's Revelations of Infant Suns. For a long time, these early stages were shrouded in mystery. Dust and gas blocked our view, but new telescopes are changing that. The James Webb Space Telescope, or JWST, is a marvel of engineering. It sees the universe in infrared light. This light can pierce through the dust, giving us unprecedented views of stellar nurseries and protostars. JWST has recently captured stunning images of a protostar called L1527. It is relatively close in cosmic terms, about 430 light-years away. The images are breathtaking. They show an hourglass shape carved out by material flowing from the protostar, illuminated by the light of the infant star. A dark line across the neck of the hourglass marks the protoplanetary disk, edge on. This protoplanetary disk is crucial. It's where planets are forming or will form in the future. JWST can study the composition of these disks, looking for water, methane and other molecules, the building blocks of planets and perhaps the building blocks of life. These observations are revolutionary. They give us a direct look at the conditions in which solar systems are born. These detailed images from JWST help astronomers refine their models of how stars and planets form. We can see features never seen before. The vibrant colors in the L1527 image show different layers of gas and dust, energized by the young star. It's like cosmic archaeology, peeling back layers of time to understand our origins. Section 6. Cosmic Giants in a Rush Rethinking Massive Star Creation. Not all stars are like our Sun. Some are much, much bigger. These are massive stars, dozens, even hundreds of times the mass of our Sun. How these giants form has been a puzzle. The traditional idea involved a slow build-up from a dense core within a turbulent cloud. But new research suggests a faster, more violent path for at least some of these behemoths. Astronomers recently studied 44 regions where massive stars might be forming. These are called high-mass starless clumps, or HMSCs. Using powerful radio telescopes like the Green Bank Telescope, they measured the conditions within these clumps. What they found was surprising. Most of these clumps were subvirial. This means they lacked enough internal energy to resist their own gravity. This suggests these massive clouds are collapsing rapidly, almost in a free fall. A much more dynamic process than previously thought for massive stars. Imagine a giant cosmic avalanche rather than a slow squeeze. This violent collapse model is new. It challenges existing theories and opens up new avenues of research. Understanding massive star formation is vital. These stars live fast and die young, exploding as powerful supernovae. These explosions create heavy elements like iron, oxygen and calcium, elements essential for planets and for us. They then scatter these elements across space, seeding new generations of stars and planets. So how these giants are born directly impacts the chemical evolution of the universe. Section 7. The Stardust Connection. Why stellar nurseries matter to us. Why do we study distant stars? Why peer into these cosmic nurseries? It might seem remote from our daily lives, but it is profoundly connected to who we are and where we came from. Every atom in your body, except for hydrogen and some helium, was forged inside a star or in the explosion of a dying star. Think about that for a moment. The carbon in your cells, the oxygen you breathe, the calcium in your bones, the iron in your blood. All these elements were created in the fiery hearts of stars long ago and far away. Stars are the universe's element factories. They make the raw materials for everything. When stars are born, they are part of this grand cosmic cycle. They will live their lives fusing lighter elements into heavier ones, and when they die, they will return these enriched materials to the interstellar medium, the gas and dust between stars. This material then forms new clouds, new nurseries for the next generation. So studying star formation is like studying our own ancestry on the grandest possible scale. We are looking at the origins of the very stuff we are made of. The formation of our sun and its planetary system followed these same processes. Understanding other stellar nurseries helps us understand our own cosmic home. Section 8. Building blocks of everything. The legacy of stars. The birth of a star is not an isolated event. It has far-reaching consequences. It sets the stage for planets, as we saw with protoplanetary disks. These disks are swirling collections of gas and dust around young stars. Within them, tiny dust grains stick together, growing larger and larger, forming pebbles, then rocks, then planetesimals. Eventually, entire planets can emerge. The type of star that forms greatly influences the planets around it. Massive stars are hot and bright, but they don't live very long. This might not give complex life enough time to evolve on nearby planets. Smaller, cooler stars like our Sun live for billions of years, providing a stable environment for life to potentially arise and flourish. The discoveries we make about star birth therefore inform our search for life elsewhere. When we look for exoplanets, planets orbiting other stars, we are particularly interested in those around Sun-like stars, in the habitable zone, where temperatures could allow liquid water. Understanding how these systems form helps us know where to look. The ongoing creation of stars also enriches the universe chemically. Each new generation of stars incorporates material from previous ones and adds its own newly forged elements. The universe is constantly being seasoned with heavier and more diverse materials. This chemical evolution is essential for the complexity we see around us, from galaxies to life itself. Section 9. An eternal cycle. The universe's ongoing story of creation. The birth of stars is not just history, it is happening now, all across our Milky Way galaxy and in countless other galaxies throughout the observable universe. The cosmos is a dynamic place, full of ongoing creation. New suns are lighting up, new planetary systems are forming. The universe is perpetually renewing itself. As old stars die, they return their material to space. This material mixes with existing clouds or forms new ones. These clouds then collapse to form new stars and planets. It is a vast cosmic recycling program. Matter is transformed but not lost. Energy drives the cycle. Gravity shapes the structures. It is an elegant and enduring process. Our understanding of this process is constantly evolving. With each new telescope, each new observation, each new theoretical insight, we learn more. The discoveries from JWST and the new models for massive star formation are just the latest chapters in an ever-unfolding story of cosmic discovery. There is always more to learn. So the next time you look at the stars, remember what you are seeing. Not just distant points of light, but the products of an ancient and ongoing process of creation. A process that connects us directly to the cosmos. We are, in a very real sense, children of the stars. And the story of their birth is also our story.